Module 4, Systems of Linear Equations. We'll start off with an application. Car Rentals Plus rents economy cars for $20 a day plus 20 cents a mile. They also offer a weekly rate of $130, which gives you 200 free miles, and they only charge 15 cents a mile after that. If you need the car for 4 days, how many miles will it take to make the weekly rate a better deal? Let's look at the daily rate. If we let M be the number of miles, looking at the daily rate, we're going to have 4 of the $20 days. So the cost will be 4 times 20 is $80 plus 20 cents a mile. So that's 0.20 times M. Alright, that's our daily rate, depending on how many miles we have. Now with the weekly rate, we're not paying for all the miles, we're only paying for the miles above 200. So we're going to pay for M minus 200 miles. Alright, and with that being the case, the cost using the weekly rate will be $130 base plus 15 cents times the number of miles, which would be M minus 200. Now solving this to figure out what the answer is, when is it cheaper to do the daily rate and when is it cheaper to do the weekly rate, we would solve a system of equations, because together we have a system of equations, 2 equations. A system of equations is a set of 2 or more equations in 2 or more variables. They can actually have as many variables and equations as you need, but for this class we're going to stick with what we say 2 equations and 2 unknowns. A solution to a system of equations is an ordered pair satisfying both of the equations. And we know how to see if an ordered pair satisfies an equation. We just plug the first number in for x and the second number in for y. So let's determine if the following are solutions to the system. Let's look at 3, 10 first. We'll plug this into each of these equations and see if it gives us a true statement. Alright, let's see. 10 equals, maybe, we hope, 4 times 3 minus 2. And 10 equals 12 minus 2. Okay, 3, 10 satisfies the first equation. Does it satisfy the second one? 3 plus 10 equals 8. It does not satisfy the second one. So 3, 10 is not a solution. So even though it satisfied one equation, it needs to satisfy both, so that is not a solution. Alright, let's do another one. 2, 6. We'll plug the 2 and the 6 in. 6 equals, we're checking, 6 equals 4 times 2 minus 2. 6 equals 8 minus 2. Oh yeah, that one's true. So it satisfies the first equation. We'll try the other one. 2 plus 6 equals 8. Well yeah, that satisfies that equation too. So 2, 6 is a solution. Alright, now let's try one more. 1, 7. 7 equals maybe 4 times 1 minus 2, and 7 is not equal to 4 minus 2. Since it doesn't satisfy the first equation, we don't even have to try it in the second one. It does satisfy the second one, but we don't even have to worry about it. So because 1 comma 7 is not a solution to the first one, this is not a solution to the set. And that's one way of evaluating to see if points are ordered pairs are solutions to a system. One way to solve a solution of equations is through graphing. Remember that a graph lists all the points that satisfy an equation. So if we have two equations represented by two lines, the place where those two lines intersect will be the solution to the system. So to solve the system, determine 3 ordered pairs for each equation and plot the points and sketch the graph. Now in reality we can use whatever method you want to graph the graph. If you want to plot the y-intercept and use the slope, whatever works for you, just plot each graph. Determine the coordinates at the point that the lines intersect, and this is your solution. So let's solve the system of equations x equals 2 and y equals negative x minus 3. So if we have x equals 2, that means it doesn't matter what y is. So I could have 2 comma 2, I could have 2 comma 0, I could have 2 comma negative 2, and if I plot those, I have a point here, and a point here, and there's my line. Okay, next we will look at y equals negative x minus 3. Let's just plug in values for x, 0 comma negative 3. As we learned in our linear graphing section, we can pick whatever x values we want or whatever y values. Negative 3 comma 0 and 3 comma negative 6. And when I plot these 3 points, there, and let's see. Yep, I am off. 0, negative 3 is here. Negative 3, 0 is there. 3 comma negative 6 is there. So we will plot that line, and it looks like we cross right there, and that point is 2 comma 5. So the solution to the system of equations is 2 comma 5. Now it wouldn't hurt for us to double check that by plugging these ordered pairs into our original equations, and they will work.